Hello everybody and welcome to lesson 8 of chapter 2, which is on slopes and equations of lines, which should be reviewed because we learned this in algebra 1. So, quick review, slope equals the vertical rise over the horizontal run. So, vertical rise is how far you move up and down. If I can draw a straight line, I don't think I can. And the horizontal run is how much I move left to right, side to side. So, in a coordinate plane, the slope of a line is the ratio of the change along the y-axis to the change along the x-axis between any 2 points. What that just means is a ratio is a fraction. Fraction of the change in y, which again is the up and down, over the change in x, which is the side to side. And we have a nifty formula for that. Slope m of a line containing 2 points with the coordinates x1, y1, and x2, y2 is given by the following formula. M equals y2 minus y1 over x2 minus x1. That is your slope formula. So on this example here, we've got a couple points and we need to find the slope of that. The nice thing about having it on a graph is that we can just count the difference. So if the rise is just the difference in the y, then let's just count the difference in the y. We start at 0, so 1, 2, 3. So our rise is 3 over our run, which is the difference again in the horizontal, moving side to side on the x-axis. So we'll start at our point and count how many we move over. So 1, 2, 3, 4, 5, 6. So our run is 6. So if we were to simplify 3 over 6, we would get a slope of 1/2. So this is the difference in the y, the up and down. This is the difference in the x, which is the side to side. And we can double check our slope. If this is our slope, 1/2, that means at every other point that we move up 1 over 2, we should get another point on this line. We can check it. We'll start here, go up 1 over 2, we end up at a point, up 1 over 2, point, up 1 over 2, that end point. And that'll work for every point on the line. Kinda nifty. Now let's find the slope of this line. We've got a point J and a point K. I'm going to label one as my first point and my second point because again I need an x1 and a y1 and an x2 and a y2. I'm going to make this point my x1, y1 point. Just cause, again, it doesn't matter. I could have chosen the other one. It would not have made a difference. This is just the point I chose. So the first thing I should do is figure out what coordinate this point is at. So, -1 is my x. That's where I am at on the x-axis. -1. And then I go down 2 on the y. So my x is -1 and my y is -2. Done. First point. Done. Now my second point, I'm going to label this one also. This will be my x2, y2. And it is at 3 on the x-axis. It is also at 3 on the y-axis. So it is at point 3, 3. Now, what I usually recommend to students who have troubles with formulas, I recommend that they label all the parts. So my formula is, again, the y2 minus y1 over x2 minus x1. That's my formula. Now, I'm going to make a little kind of like key over here where I'm going to put everything, all my information that I need in. So my x1, my y1, my x2, and my y2. That looks like an x, but it is a y. y2. So my x1, again, that's the x from my first point, which in this case is -1. My y1 is the y from my first point, which is -2. My x from my second point is 3, and then my y from my second point is also 3. Now that I have my little key filled out, I'm going to plug all of this into my equation. So instead of at y2, I'm going to write what y2 is. It's 3. So I put it in parentheses so I can see that I put something in there. Minus my y1, which is -2. Again in parentheses. Over my x2, which again is 3, minus my x1, which is -1. Now, when I have two negatives like that, those become positives. Negative times a negative is a positive. Same down here. So what this is saying is 3 plus 2 is 5. 3 plus 1 is 4. And again, this nice thing is it is on a graph, so I can check my work. This is going to be how much I move up or down. In this case, it is up because we're going positive. And 4 is left to right, in this case right, because again, positive. So let's go up 5. 1, 2, 3, 4, 5. And right 4. 1, 2, 3, 4. Did I end up at a point I was supposed to? Yup. Is my slope right? Yep. Done. Easy. And again, this should be a slight review from Algebra 1. Next one. Ooh, this is a tricky one. This is a vertical line. Vertical lines are special, but let's put it through our slope formula to try to see what kind of slope it has. We've got a point Q and a point R. Point Q is at 2, 1. 2 on the x, 1 on the y. And point R is at 2 on the x and 1, 2, 3, 4. -4 on the y. So again, let's put our little key over here, x1, y1, x2, y2. My x1, let's make this one x1. My x1 is 2. My y1 is 1. From my first point, this will be x1, y1. And my x2 is going to be 2. My y2 will be -4. Now let's plug these into our equation. We've got y2 minus y1 over x2 minus x1. Plugging them in. Y2 is -4 minus 1. Sorry, my pen is freaking out. Woo. Over x2, which is 2, minus x1, which is 2. Make that look a little neater. There we go. Now let's simplify this. -4 minus 1 is -5. 2 minus 2 is 0. So here's the tricky part. Can we have a slope of, or a number being divided by 0? We cannot divide by 0. So this is a no-go. So this is what we call an undefined slope. So when you see a vertical line, you can just go, oh, that has an undefined slope. You don't even have to do all this. You can just know a vertical line has an undefined slope. Let's do some of this guided practice down here. I'm going to just do a couple of these. I'd like for you to try these more on your own. Let's do the first two. Oh, that's the right pencil. There we go. Okay, so we've got a couple points. Let's plug them into our equation. Let's make this one x1 and this one y1. Just cause. You could switch it. It doesn't matter. x2, y2. So let's just plug these into our equation. y2 minus y1 over x2 minus x1. My y2 is negative 5. So negative 5 goes here. Minus my y1, which is negative 2, over x2, which is negative 3, minus x1, which is 6. Let's simplify this. Two negatives make a positive. So negative 5 plus 2, which is negative 3, over negative 3 minus 6, which is negative 9. Minus 3 minus 6. When I have two negatives being divided, those make a positive. So this is a positive slope. 3 over 9 is simplified to 1/3. And we are done. Okay, and let's do the second one. Again, we've got 2 points. We're going to call one x1, y1, x2, y2. Let's plug them into our equation. y2 minus y1 over x2 minus x1. Instead of y2, I'm going to put minus 2 minus y1, which is negative 3, over x2, which is negative 6, minus x1, which is 8. Again, with the double negatives, negative negative makes a positive. So negative 2 plus 3 is just a positive 1 over negative 6 minus 8, which is negative 14. So our slope is negative 1 over 14. I kind of just readjusted the minus there to kind of put it out front instead of just with the 14. If you want to leave it there, it's not a big deal. This is just more how we would write it. So in this slope, if we were to have a line, this negative would mean instead of going up on the 1, we would go down. Or on the run, we still go to the right. This one's positive, we go up and then to the right. There we go. So this says, write an equation in point slope form of the line with a slope of negative 3/4 that contains the point negative 2, 5. So point slope form is y minus y1 equals m x minus x1. This is point slope form, where you have m, which is the slope, and we have x1, which is x of a point and a y of a point. So we have a slope and we have a point. That's why it's called point slope form. So in this case, my slope is, or m, is negative 3/4. And my point, which is x1, y1, is negative 2, 5. So I'm just going to take this info and plug it into my formula. So instead of m, I'm going to write, or let's start with the y1 because we need that first. Y minus my y1, which is 5, equals my slope, which is negative 3/4, x minus my x1, which is negative 2. And again, when I have negative times a negative, that becomes positive. So if I were going to rewrite this, y minus 5 equals negative 3/4 x plus 2. Now, if I were to graph this line, I would go to my point on my graph. This is my graph. Negative 2, 5 will be somewhere up here. And then my slope of negative 3, 4, that tells me to go down 3 and then to the right 4. So let's go down 3, 1, 2, 3. It's kind of hard to see. 1, 2, 3. And then to the right, 4. So 1, 2, 3, 4. So my next point is going to be right here. I know it's not a very exact graph, but that's as good as they're going to get without a coordinate plane. Weird, it also gives it for us here, but you can see it's kind of similar. Good. Great. Next. So, slopes of parallel lines. These are some more theorems relating that back to the proofs unit. Parallel and perpendicular lines. Parallel lines are two non-vertical lines. They could be vertical, but they have the same slope, if and only if they're parallel. All vertical lines are parallel. So, if you look here, line L and line M have the same slope. They have a slope of 4, both of them. So they are parallel lines. Parallel lines never intersect. So, if they have the same slope, if they're moving at the same rate, they will never, ever, ever cross. Perpendicular lines are two lines that have different slopes, but the product of their slopes, product meaning multiplication, when you multiply them, their slopes are -1. So, vertical and horizontal lines are perpendicular. In this case, we have a slope of 4. This line, P, has a slope of -1/4. That is a perpendicular slope. When you multiply 4 times -1/4, you get -1. So let's do a couple examples. In this case, we have to determine whether line AB and line CD are parallel, perpendicular, or neither. So let's first find the slope M of line AB. So this will be the AB slope. So A is at -1, or not negative, +1 and +1. And B is at -1 and -5. And I'm just going to label those my x1, x2, y1, y2, respectively. Here we go. Now again, we'll plug those into our slope equation, y2 minus y1 over x2 minus x1. So first, my y2 is -5, so -5 minus y2, which is 1, over x2, which is -1, minus x1, which is, again, 1. So -5 minus 1, that's -6, over -1 minus 1, which is -2. -6 divided by 2, if you were to put that in your calculator, you would get a +3. So my slope of AB is 3. Now we need the slope of CD. So CD slope. I'm going to call it M again. Ooh. CDM. So following the same equation, I've got x1, y1, x2, y2. So y2 goes first, 1 minus y1, which is 2, over x2, which is 6, minus 3, which is x1. So I get 1 minus 2, which is -1, over 6 minus 3, which is 3. Now I need to determine if it's parallel, perpendicular, or neither. So parallel would mean they're exactly the same. Are they exactly the same? No. So they're not parallel. Could be perpendicular. I need to test it. Neither, also a possibility. So to test if they're perpendicular, I just need to multiply them. If I multiply 3 times -1/3, do I get -1? Yeah, I sure do. So these two lines are perpendicular lines. Perpendicular. This is also the symbol for perpendicular. In case you didn't know, it looks like an upside down T. So that's kind of fun. Okay, let's do another example. We've got a couple. Let's just choose one. I choose the second one. We're going to do this one. Boop. We need to, again, determine if they're parallel, perpendicular, or neither. So let's do the AB slope first. So, x1, y1, x2, y2. So if let me rewrite the equation up here again. So first thing that comes first is the y2, so 2 minus y1, which is 6, over x2, negative 9, minus 3. Simplify that. 2 minus 6 is negative 4. Negative 9 minus 3 is negative 12. Simplifying this even further. 4 and 12 are both divisible by 4. So, and again, the two negatives, those make a positive, so this will just be a positive 1 over 3. Cool. So that's my first slope. Now I need to do the CD slope. So this will be my x1, y1, x2, y2. Plugging those in. I get y2 first. No, it looks like a 2, that's a 1. Y2 first, which is 3, minus y1, which is 4, over x2, which is 2, minus x1, which is 5. Simplify this. I get 3 minus 4, which is negative 1, over 2 minus 5, which is negative 3. So negative 1 and negative 3, those are both negative, which means they're actually positive. So that is just a positive 1, 3. Now, parallel, perpendicular, or neither. Parallel means they're exactly the same. Are they exactly the same? Yep, they sure are. They're both positive 1/3. So these are parallel lines. Ta-da! And we are done. So, take a look at the homework. Come prepared with questions. We will see you in class. Bye!